BrainCube is an industrial IoT platform that continuously collects, structures, and contextualizes your data. It comes with ready-to-use business and expert apps designed to inform, report, and perfect your manufacturing operations. BrainCube's data visualization apps make it easy to access your vital production insights in a comprehensive customized dashboard. A low-code, no-code environment with a large choice of ready-to-use charts and widgets empowers your teams to build custom and interactive dashboards for real-time and historical production data. You can navigate between dashboards, easily build advanced charts to make descriptive analytics or identify trends, all from a single platform. This is an example of the quality follow-up chart. The upper part shows the quality measurements with tolerance limits, while the lower gray bars display weekly production levels. Before diving deeper into the quality analysis, let's have a look at the data preparation with BrainCube Digital Twins. BrainCube Digital Twins are a gathered, cleansed, structured, and contextualized database that encapsulates the precise production conditions for every individual product. Here, we are working with the company's process experts to build the process map. It allows us to calculate lag time, identify any missing data points and gaps where we can use calculated variables. This is a workflow in BrainCube's proprietary middleware to build digital twins. In this environment, we have dozens of connectors and pre-configured functions available in the library. You can see that we are connecting data from different sensors, systems, and APIs. In addition, we are also making some data transformations, like filling, aggregating variables, and using custom formulas to make advanced calculations. On the next stage, we are creating groups to dispatch all the collected data into the right place. They correspond to the production steps that we previously defined in the process map. Once the groups are created, we tag each variable and link it to the related process stage or production asset. Next, we have to ensure that the data follows the physical flow of our product. For this, we align data by calculating the time spent between the beginning and the end of each process step. We configure all the groups and interlink them together in order to create the digital twins. When the digital twin is complete, we deploy the model in the BrainCube environment. Now that the data flow is configured appropriately, it can be used across the organization to work on multiple goals. Today, we're going to take you through a quality optimization use case. In the data visualization section, we built a quality KPI chart that we're going to use here to create an analysis with the goal of improving the quality variability. You can launch an analysis in one click and choose the type of analysis to run. For this, you select the KPI to address, for example, quality. Choose the time period to include. Select and filter variables to analyze, for example, specific product reference. You can also remove any non-relevant events like maintenance periods. Here, you can define the target for your analysis. The AI algorithms will spit production data into more and less performing runs to uncover why some of them are better than others. Then, you select the variables or group of variables you want to include in the analysis. Finally, you set up the description and the privacy of your analytics study. By saving it, you'll have easy access to revisit the final results. On this page, you have the analysis summary, the points distribution, and the different views of your quality KPI that can be easily shared with your teams. To understand which parameters influence the quality, we use BrainCube's Cross-Rank AI. This is a data mining tool designed to automatically sort through your historical data to identify all of the variables in your process and rank them from the most to the least impactful one by attributing a score. Now, a process expert will notice some interesting process variables to explore, for example, temperature and water control valves. Let's have a deeper look at the supply temperature. In the lower section in blue, you can see the distribution of historical temperature data. This shows us that 131 times within the analyzed period, the product was produced with a supply temperature between 11.8 degrees Celsius and 12 degrees Celsius. The upper green and red bars indicate a positive or a negative impact on our quality KPI. Here, the green indicates that the quality performance was 21% higher when we operated at this temperature. Now, the local engineering or production teams can decide what to do, combining this data discovery and their process expertise. For example, they could create a rule or new production standard that will include this variable. From a few clicks, we can put the operating settings that will result in the best quality performance. It's interesting to keep going step by step to find the variables that make the most sense for your team. Here, we analyze the water control valve and also to find the optimal setting ranges for this variable. We have identified another variable that is a fluid bed differential temperature that we will also add to our analysis. Being able to leverage AI to uncover variation helps to save teams time, money, and resources. Now, let's assume that we've identified some setting optimizations we want to apply. We are going to take these 3 selected variables and push them into a rule so that they can go directly to the shop floor. In the bottom part of the screen, we can see the selected parameters with the defined setting ranges. On the upper charts, you can see the expected quality improvement of plus 5.81%. The rule presence indicates that we have already done the configuration 17% of the time in the past, so we can reproduce it again. Now, we are going to activate this rule and define the new production standards so that the operators can directly visualize live instructions to guide them. Here, we are in the control room and can monitor the variables that we put under control with the rules. You can easily see all the parameters, and when some of them are out of spec in red or orange zones, the operator will receive an alert to address them immediately. To ensure quality control, let's run a report to see how our rules performed. We can compare different active rules, view their average application rate, results, and various trends that we can easily share across the organization. Braincube.com